Hello, hello. Is it recording? It is recording. Okay, great. All right. Today we'll be doing another subset question. It's called permutations. I think we all learned this back in like middle school or something. But if you're anything like me, don't remember exactly how it works. Yeah. Also, I think I know how it works. It's just I never really implemented it in code before today. So with that being said, yeah, we're going to be doing this problem today. Um, yeah, I don't know what else to say, so we will read the question. Given an array nums of distinct integers, return all the possible permutations. You can return the answer in any order. Um, yeah, I guess there's not much. Basically, you just want to rearrange this basically in every order possible, which is the definition of a permutation. And yeah, um, I guess without further ado, we can get right to it. We need to initialize a few things for us to use in this question. Um, First, we're going to need an empty result array because we have to somehow build our result. We're going to do a nums_len, which is just equal to the length of nums. I'm not sure if this is actually needed or not because you realistically only really call it in one place, but um, I don't know. It's probably still it's. I'm pretty sure it's just an O of one operation anyways. So don't really think it's all that important. But I did use it in my solution, so we'll use it again here. And then we're going to be initializing this last thing called permutations. It's going to be in ODQ. Um, Actually, maybe I shouldn't call it permutations, but it's something like a work in progress. So as we build our solution, we will be using this DQ. You know what? Here, we'll just call it a work in progress. Whip. Probably don't want to use that in an actual interview, but in this case, we're just gonna use whip. Um, yeah, we'll just use whip, and then we're going to append the empty list because we got to start out somewhere building our solution, right? So now we need a few for loops. We need for num in nums because we obviously need to go through every number here in order to build out our solution. We will be taking a variable called whiplen, work in progress length. This one we need definitely for sure because this length will be changing throughout um, the course of our for loop right after this. So, and we don't want to use too many or too little. Um, I guess it's not really too little, but too many work in progress permutations. So we actually need to store this variable for sure. We're going to be doing for blank in range. This basically just means you won't be using the variable. It's just going to be empty. It's just there. So for blank in range of whiplen, we want to get the current whip, current work in progress permutation. We're going to acquire it by doing whip.pop left. That's how we get our current work in progress permutation. And now for j in range of the length of cur whip plus 1, because we want to hit every index. And so let's just say we're currently working in progress. The way we built it out, if we have 2, if we handled 1 and 2 so far, we need to put a 3 in the beginning, middle, and end. So we need to hit everything of it, right? So we need to hit indexes 0, 1, and 2 for us to insert the values. So that's why we have to do the range. Oh, we have to do the length of the current whip plus 1. And then so we'll just create a temp whip, which is equal to the list of current whip. This we're literally just making a copy of current whip right now. And then so we got to do temp whip dot append, or not, sorry, not dot append, sorry, dot insert at index j, we want to insert the current number we're looking at, num, right here. And then if the length of temp whip is equal to num's len, so that's where we use this variable that we did. You know, if you don't have the variable, you just end up doing the length of nums. I don't think it really changes anything, but we'll just do nums len here. Then if it's equal to the length, that means if what we've built here is the length of our regular array, that means we have no numbers coming up, right? So that just means we need to do result.append temp whip. Else, which means the length is not equal, we shouldn't have, there shouldn't be a world where we somehow have a greater, like a length greater than. So if that means it's just less than, right? That means we still need to build upon it. So I almost did permutation. We're gonna do whip.append temp whip, and then you exit out of all the for loops. You hit the return result right there, and it looks good to me. I think, let me go through it once again. I can also explain the solution here, actually. So while I will be reviewing the solution just to make sure nothing's wrong while explaining the solution. So basically, we start off with the empty, for the work in progress permutation, we're going to start off with the empty one, right? And so we get the length of the whip, which is 0 for the first number, right? So we're looking at 1 right now. Length of the work in progress right now is just 1, actually. Yeah, because it's for this for loop. Sorry. Let me backtrack. So we get the length of this, which the first time we go through is just 1. So we lock in the number 1 right here for blank in range of whip len, and we start at 0. And then next one is 1. So we only get this for loop once. The current whip, we pop left off of the DQ here, which would be this first what do you call it? This first empty list. And then for j in the range of length of current whip, and the current whip is length 0. So we need to go to 0. So it's for range of 1. So that means we get to do one operation. We make a copy of the current one. We insert at index 0 because it's the first time. We insert the 1. And then since it's not equal to the length of the list, we append it to whip. So now our whip looks like this, right? So now we're at the number 2. We come down, you know, the length here is still 1 because we only have one thing here. We go in, this is also, we'll just go through once. We pop it off the left for I in range of the length of current whip. The current whip length is 1, so we not go to 2 because the range is from 0 to whatever numbers. Since we didn't specify a start, 0 and 1, we make a copy of it called temp whip. We insert at index 0 the number, which is 2. So then now this is popped off. We insert a 2 1, and then we insert a 1 2. Oh my god, I can't. So yeah, there we go. Now we have, you know, our 2 1 and 1 2. And then we'll do this again. The length of this is 2 now. So we'll do this twice because we have to pop off this one, and then we have to pop off this one, right? You got to do that twice. And so we first pop off the 2 1. We have to insert the 3 in the first second slot. So we'll 3 2 1 2 2 3 1, and then 2 1 3, right? That's what we get after popping off the 2 1. And when we pop off the 1 2, we get 3 1 2 1 3 2 1 2 3. Right? And then those are our 6 solutions. So that's how the solution works. Seems like it does work. So yeah, let us submit the solution. And it works. Yeah. So with that being said, thank you for watching.